in parallel universes. All of quantum mechanics, which in turn is all of physical reality and all of life. Everything you know and love is based on quantum mechanics. Quantum mechanics in turn is based on the multiverse. And we're not talking about Marvel Comics. We're not talking about Spider-Man and Marvel Comics in multiverse. We're talking about the laws of physics are defined in a multiverse. Now, how do you explain the multiverse to an average person? I once asked Steve Weinberg, Nobel laureate, to explain the multiverse in a simple way. And he said, well, look, take a look at radio. If you walk into your living room, how many radio stations are there in your living room? Hundreds of radio stations, right? But your radio is only tuned to one frequency. Okay, it resonates at one frequency, and that's why you hear only one station. But how many stations are there in principle in your living room? Hundreds of vibrations, okay? Now replace the radio with electrons. The electron is a wave governed by quantum mechanics, okay? And how many waves are there of these electrons? An infinite number of waves, just like infinite number of radio waves. But you are tuned to one frequency. That's why you exist with parallel universes. In your living room, there are dinosaurs. In your living room, there are pirates. In your living room, there are aliens. You don't have to go into outer space to see the aliens. The aliens are there right there in your living room. The thing is, you are no longer vibrating in unison with them. You've bifurcated. So you cannot jump into these other universes unless, of course, you are an electron. Electrons do this all the time, okay? And what is that called? That's called electronics. All of electronics are based on that idea that electrons can be in multiple states at the same time. That's why you have laser beams. That's why you have the internet. That's why you have all the wonders in your living room. It's because electrons can be in multiple states at the same time, okay? Now, why can't you enter these other realities? Well, for the PhD exam, we sometimes give a simple question to our PhD students. Calculate the probability that you'll wind up on Mars tomorrow. Now, the average person would say, that's a stupid question. You got to be an idiot. What? Calculate the chances you're going to wake up on Mars tomorrow? That's a physics question. Electrons do it all the time. The question is, can you wake up on Mars tomorrow? Okay? So you do the calculation. Heisenberg uncertainty principle, delta P, delta X, H bar, so on. You do the calculation. And you have to wait longer than the lifetime of the universe for that to happen. Chances are you're going to wind up in your bed tomorrow. But there's a small probability that you'll wind up on Mars tomorrow. That's the quantum theory. The quantum theory computes on multiple realities. So the question is, why are quantum computers so powerful? They compute on parallel universes. That's why they're so powerful. Now, we usually don't like to teach our students this because it freaks them out. So we simply say that the electron, it's like a football. You know, you took chemistry, right, in high school?
Of course.
In high school chemistry, what was the electron? How did you visualize the electron? It was a football, right? A football that was surrounding the nucleus of the atom. That was the picture given to you by your chemistry teacher. They didn't tell you the truth because it would freak you out.
I knew she lied to me.
That's right.
Miss Pomeroy was on some.
That's right. The electron is not a football. The electron is not a wave that looks like a football. The electron is not a wave at all. The electron is a particle that exists in multiple states at the same time. In other words, this is straight out of Marvel Comics. In fact, where did Marvel Comics get the idea of a multiverse? It came from physics.
Right. I just don't know how. I mean, what is the meaning of it all then? Like, sitting right here, right now, if this is the case, and there's all these multiverses, which are these infinite probabilities and possibilities, what is to say that we're not completely simulated in one separate multiverse right now, and in another multiverse, you're an axe murderer, or not a scientist at the very least, or something totally different, right? Like, what is to say that this right now is happening and you and I are both present and understanding a similar experience of the world as we know it today?
Well, like I said, we usually don't teach this to our students because it freaks them out.
Yes.
But hey, get used to it.
Yeah, I'm very
This is the
freaked
way
out.
the reality is. Okay, reality is not there to make you feel comfortable. Reality is the way it is. Get used to it. Well, when I walk across the room, I have this picture that it's just not me walking across the room. There are hundreds of parallel me's walking across the room with me, each one thinking that they are the unique version of me. When I look in a mirror, I ask myself this quite constantly. When I look in a mirror, is that really me? No. First of all, it's me 1/1000th of a second ago, because it takes a billionth of a second for light to go from my face to the mirror to my eyeball. It takes about a billionth of a second. So I'm looking at me a billionth of a second ago. I never really see myself as I really am. And then with quantum mechanics, I'm surrounded by other versions of me. Surrounded. And some of them decide to go outside, get breakfast. Some decide to go to the bathroom. Some of them decide to go to the library. And it's all me. Okay? And you begin to freak out thinking about this.
I'm very freaked out right now.
But my attitude is, get used to it. This is the way reality is. And this is the reason why quantum computers are so powerful. And that's why flowers